Okay, good morning class. This is our lesson today. Today we're looking at relations and functions. This is really similar to what we've already been doing, except slightly different. So we're going to look at those similarities and differences throughout this unit and note what they are. And this unit also is going to look at interpreting graphs of real life situations. So a lot of its applications of what we've learned already. So the slope, what does it mean? Your intercept, what does that mean? And then how that's graphed and what's the rate of change, which more or less is your slope. So today what you need to do is you need to access the class website, which you've already done. You've gone to Math 10 Notes Monday, April 7th, which you've done, and you've downloaded those. So hopefully you've printed them off because you can print out completed notes. So when you're away, you don't have to save time. So you don't have to waste time copying out by hand. You should have always a printed set of notes. You should have printed those notes and retrieved from the printer unless you plan on watching the entire video per length and going and doing your homework afterwards. I recommend printing the notes. Save yourself some time. A lot of today's stuff is going to be definitions which you don't need to write down. You can look at, then understand and interpret as you watch the video. So right now you're watching the videos. You should only watch the parts that you do not understand. So you can fast forward. So what you can do if you don't understand anything, fast forward to what you're trying to understand. So if you're stuck out for homework time, fast forward to the question that's similar. We always cover our homework questions and they're always similar to our notes. You need to take your notes and compare that to your homework. That's really important. There's extreme similarities between your notes and the homework. Okay, so make sure that you go and do that. Then, after you watch the video, you can complete your homework assignment as per the unit outline. Okay, so complete the homework assignment as per the outline. Good, let's get started. So we're looking at relations and functions. What we looked at last unit was functions. Now we're also looking at relations, and we're going to take some more in-depth look at functions and see what they are. So relation is an association between two quantities. They're related, okay? Cousins, whatever you want. So what we have is we have an independent variable, which is usually our x variable. Okay, so we plot it on the x-axis. We'll cover that in more detail later. And the other is the dependent variable, which is your y variable, and it's on your y-axis. We'll talk about how to do how to come up which one's independent and which one's dependent later. Usually we put a depends on sentence. So our our y depends on, because it's dependent, x. Again, we're going to look at that in more detail later. What we would do is fill in with our units. Okay. So we use our units to come up with the correct sentence to determine exactly which ones are y and which ones are x. Again, more on that later. Now, relations can be expressed in words, okay, as an equation, as ordered pairs, or in table values, or simply as a graph. And so we have to look at each set and determine whether we have a relation or whether we have a function. All right. So express the relation, the dependent variable is the square of the independent variable. Okay. So dependent variable is y, is the equal sign, the square of the independent variable will be x squared. So then we can take that information and put that into the equation y equals x squared. What we can then do is come up with some ordered pairs. How we come up with ordered pairs is we start with the table. So number one, try and make your equation. Number two, come up with a table. Now a full, complete, accurate table should start at -3 and then work your way down. Okay, that way we can see what occurs and what's happening with a larger picture of the graph. So we can cover all of the y-axis, the x-axis, as we're crossing the y. So to figure out what this is, we just substitute into our equation. Y equals -3 in brackets squared. And so we get a value of 9 for y. Y equals -2 squared. And so we get a value of 4. Yes, you must have brackets. It's extremely important. Otherwise, you would have negative answers if you're doing the math correct. And then we can fill in 1, 0, 1, 4, 9. And you can see there's a bit of a pattern there. From the table, we can then write our ordered pairs. Now, sometimes we'll be given the ordered pairs to start with, and you have to go back and write your table. Okay, so I should really erase 1, 2, and 3, because it's not really necessarily the order that you're given, it's what you can do with it. So the ordered pairs are -3, 9 in brackets. Okay, then another ordered pair would be -2, 4 in brackets. -1, 1 in brackets. 0, 0 in brackets, and so on and so forth. So all we're doing is taking ordered pairs from the right, the table from the right, and writing as ordered pairs. It's just a different format of writing the exact same thing. And then what we can do is take our ordered pairs and plot them on the graph. So from ordered pairs, we can go to the graph, or vice versa. If we start with the graph, we can go backwards. So all you're going to do is plot these points. Now this is a special graph that you haven't seen, and we're not going to see a lot of it until next year. But when you plot all those points, 2, 4, 1, 2, 3, 4, 2, 4, we get a special shape called a parabola. Okay, and the next one is up top. And so you can see there's a trend, and the trend actually continues. So what we do is we make a nice smooth curve. Oops, and we should have arrows on there showing that this U-shaped graph continues forever. So this is called a parabola. Now, other than looking at it, you don't really see it until next year. Next year, you do a lot more with this graph. So here, this relation has 1, 2, 3, 4 ways of writing it. You can see it as an equation, as a graph, in ordered pairs, or as a table. You should be able to go back and forth. At this stage in the game, you will not be able to come up with a parabola equation, but you'll be able to see a linear equation later on. This is not a linear equation. It is a parabola. Okay. So, some more definitions. The domain. The domain is a word that we refer to as the independent variable. Now up above, what's the independent variable? It's your x value, okay, or your x variable, your x values or your x words. It is the first set. Now, sometimes we use words, right? For example, for graphing fruit, it is the first coordinates in the ordered pairs, which is basically saying it's our x. Okay, the range is your dependent variables, and it's going to be your y values, which is, it's the second coordinate in the ordered pairs. So that's what a relation is. Next, we're going to go to a function. It's just a special type of relation. So almost everything that we're going to graph is a relation, but this one is special. The functions are special. And what we've been graphing has been functions. We don't always graph functions. So the 3 points that make up a function, number 1, each value of the independent variables, or independent, has only one dependent variable, dependent value. So often what you're going to hear me say is this. One output per input. And another way of saying this is that for every value in the domain, which is your independence, there is a unique value in the range. So it's the exact same thing that we said above. It's just worded using domain and range. So these are identical. Now these are also identical. Okay, all three mean the same thing. So what you're going to hear me say though, there is only one input for each output. And that's what you're going to hear me say. These are all the same meanings. So what we have is we have input. We put that into our equation. And then we solve for our output. Okay, that's essentially what's going to happen. Now, sometimes our equation can be a little special. We'll show what you mean in a second. Okay. So we're going to determine which ones are functions using an arrow diagram. So this is going to be our inputs, and this will be our outputs. What we do is we put the data of our inputs down on the right, sorry, left, but rather 0, 1, 2, 3. Okay. Our outputs will be 1, 2, 3, 4. So when we input a 0, we get an output of 1. When we input a 1, we get an output of 2. When we input a 3, we get an output of, input a 2, we get output of 3. When we input a 3, we get an output of 4. So what's the relationship? Well, the relationship is the input, and then we'll go plus 1 equals the output. So the input plus 1 equals the output. So 0 plus 1 is 1, 1 plus 1 is 2. So this here is the relationship. And usually we write it in the middle. Now, is this a function or is this just a relation? We know it's a relationship, but if you notice there's only one output for each input, so yes, it is a function, not just a relation. Okay, it's a special relation. Let's look at number 2. Okay, so number 2, we have 4, and we get a 2. We have a 6, but we have a 3 or a 2. So a 6 can be either, that's kind of weird, and 8 we have being a 2. That's okay, right? It's okay that 8 and 4 can be the same thing, but it's not okay that 6 can be two different things. Okay, so this is not a function. And the reason is because there's 6 has 2 outputs. Okay. 6 can be a 2 or a 3, and that's the problem. Okay, it's different. The input has 2 different outcomes. Now, what's the relationship here? The relationship is these inputs have prime factors of these outputs. Okay. So one thing to note is that we didn't list 2 and 3 more than once. Okay, what we do here, when we list the elements of the domain and the range, we do not repeat the elements. Okay, so we only had a 2 and a 3, not a 2, 2, and 3. Okay, so that's important to note. We don't list it more than once. And we do the same thing for the inputs as well. Okay. So one is a function and the other is not a function. You need to know the difference between them when you're given this diagram, or make up the diagram. Okay. Turn it over. Next page. Number 3. So here's our input. We input a 2 and we have an output. What's the relationship between these numbers? 20, 30, and 31. What's a 20, 21, sorry, 20, 30, and 31? What's the relationship? Well, the relationship is this is the number of months. Sorry, the month, not the number of months. The month has this many days. So month 2, which is February, has 28 days. That's what we're graphing here. We're using an arrow diagram. Okay. So month 4 has 30 days, and month 6 has 30 days. This is okay. This is a function. Okay. The reason why is because each input has one output. It is okay that 4 and 6 both have 30 as their output. That's all right. Okay. There's nothing wrong with that whatsoever. Okay. Next one, number 4. Is this a function? Yes, it's a function. Okay, so it's a relation and it's also a function. Again, because each input has one output. Okay, so that's fine. What's the relationship? -1 and 1 equaling 2. Sorry, -1 and 1 equaling 1. The relationship is the square, right? So the input squared is the output of 1. -2 squared is 4, and 2 squared is 4. So this is a function. An example of not a function, one more time, would be something like this. If you had input of 2, and say it had a value of maybe 7 and 20, that would be an example of not a function. So one input has 2 different possible answers. Keep that in mind as you're looking through your homework to test whether it's a function or not. This is not a function, it's just a relation. Okay. Not a function, just a relation. So functions are special relations. Now what we can do if we have a graph is we can use what we call a vertical line test. It's a special test to see if a graph represents a function. So if a vertical line and in the textbook, or you might even hear it being called a pencil test, because you can use your pencil as the vertical line. So the vertical line intersects, which basically means touches, the graph at more than one point, so more than once, the relation is not a function, just a relation. Is not a function. So I'm going to use a vertical line, nice and big. here, if I take my vertical line and I move it from one side to the other, at any time, the vertical line is only being touched at one time throughout the graph. So this one is a function because it passes the vertical line test. Compare that to this other one right here. I draw a vertical line, guess what? It's being touched in two spots, right here and right there. So here, it's being touched twice. So it fails the vertical line test. So because it fails the vertical line test, it's just a relation, not the function, just a relation. Look at the next example. Does it pass or fail the vertical line test? Well, if we make our vertical line, you can see when you move it along the graph that anytime as we move it, it only touches it once. So this one passes the vertical line test. It does not fail it. And so we can say that it is a function. It only touches it once, right there. Okay. Here it only touches it once. Next one, what do you think? Function or relation? Have a look. Well, it does touch it more than once. Okay, so it touches it at this spot here and that spot there. So again, it's just a relation because it fails the vertical line test. So far what we looked at was up here. We looked at, the arrow diagrams on what a correct arrow diagram of a function is and what an incorrect arrow diagram of a function. So this one is just a relation. This is a relation, whereas this one is a function. So we looked at what the arrow diagram would look like in order to be a function. And we looked at what the graph must look like in order for it to be a function. So what about this tricky one here? Does this graph represent a function? So if you look at the vertical line test, and you do the vertical line test, it looks right at this point here, these points here, that it fails the vertical line test, when in fact it doesn't. Okay, so the way what we have here is this point is not included because it's an open circle. So we have our inequalities graph. What happens is right at that point it jumps up to here, which it is included. Okay, so the point is included because it's a closed circle. So in fact, this is a function because it passes the vertical line test. It passes the vertical line test. Remember with our inequalities, if x is greater than, this would be y values. If y is greater than 3, we would use an open circle. Whereas if we have y is greater than or equal to 3, then we use our closed circle. Okay. So this graph here is a function. Now if I just did a quick example of an inequality type graph which is not a function, it would look something like this. Okay. We start, we go to this point, and right above it would be another closed line. Because it's doubling up, it's not a function. It's not a function because there's two outputs. Right? It fails the vertical line test. Right? So if I did a better example, let me just quickly change this so you can see the example. Let's go view. Oh, that won't even work. You know what? I'll do an example down below here. Okay. And increase some more space. View, rules, we want a grid. Can we get a grid? Perfect. So if we get a grid, and just quickly draw a graph. Okay. There you go, nice and pretty. So if I did an example of right here at y equals, shaded in, straight line, open circle. Then we jump up to this point, straight line, open circle. We're still at a function. This is still a function. Okay. Circle, go. But now, if I used here, now it's not a function. It's not a function because x equals 2 can be two different things. X equals 2 can be a value of 2, or x equals 2 can be a value of 4. So there's two different y values. Now, a proper arrow diagram would be something like this: 2, and 2 and 4. And so you can see that there's two different outputs. So that would not be a function. Okay, so this is okay. Here it's okay. But at the second part, it's not okay, because we can have two different values, and that's what we don't want. Okay, so there's our lesson. Time to go and make a chart. Sorry, time to go and do your homework.